On question number 3, it says, to save time grading, professor asks just one question on a test that's graded either right or wrong. Suppose each of the 100 students knows 80% of the answers to potential questions. Approximately how many students will fail the test? So if 80% of the students, suppose each of the 100 students knows 80% of the answers. So if we look at that, so the probability that an individual student will get the question right is 0.8. So the probability they get it wrong is 0.2. So that they fail, the probability is 0.2 out of 100. 0.2 times 100 would be 20 students would fail the test. Okay. So anyways, that's looking at that one. Question number 4 says, suppose .com entrepreneurs want to know what percentage of people use the internet. They send a questionnaire to all email addresses asking whether the recipient uses the web. What percentage of the respondents is likely to say that they use the web? Um, so it's probably safe to assume that all the people that were sent surveys have access to a computer and the internet, or else they wouldn't have an email address. So the ones that respond back are probably, we're going to get 100% of them that say, yeah, I use the web, because um, they have to have used the web to get the email. So that would be a biased survey and not a very good one to do. So most likely that would be 100% of the people that would do that. Voluntary grade inflation. The dean felt that a professor had graded too harshly, so she wrote a questionnaire to all students asking if they would like their grades reevaluated. Of those students who received a grade of A, how many would you think responded to the dean? Well, if they got an A, most likely they don't think that they were graded too harshly. They got an A. They don't want somebody to go back through the grades and be like, "Hey, don't let's look at this." And they don't want to have you go back through their grades. If they have an A, they maybe their grade might drop. They don't want that. So you'd probably get 0% of those. So again, that's biased. We don't want to do that. So, Dr. Die, suppose you doctor a standard 6-sided die by changing the face with 3 dots into a face with 5 dots. So your die now has 2 faces with 5 dots and no face with 3 dots. Sketch a histogram of the theoretical distribution of the frequency of each outcome. If you're to roll the die, can't remember how many, I don't know if that's 60 or 600 times. We'll just say it's 60 times. So a sixth of everything would be 10. So a sixth of the time would expect, so the ones, a sixth out of 60 would be 10. The twos would expect to be 10 times. The threes, there's no longer threes. The 4 would expect to be 10. Now the fives, because there's two-sided, would be 20, and 6 would be 10. So if I did a histogram, would have ones, twos, threes, fours, fives, and sixes. And then up here would have like 10 and 20. So then you would just come over here and you'd, so at 10 you'd have, or at ones you'd have 10, twos would be 10, threes would be 0, fours would be, fours would be 10, fives would be 20, and sixes would be 10. So it looks something like that for a histogram on that. Okay, so number 8 says a podiatrist in the making. Suppose you ask the shoe size of each female in your dorm and discover that the data have a normal distribution with mean of 7. If the standard deviation is 1.5, approximately what percentage of women have shoe sizes in the range from 5.5 to 8.5? What range of shoe sizes would include approximately 95% of the women? So here we go. We draw our normal bell curve. The mean is 7. The standard deviation is 1.5, so this next one would be 8.5. The one down here would be 7 minus that. So 7 minus 1 is 6, minus another one would put us in the 5. So that's 5.5. So there we go. That gives us the range from 5.5 to 8.5. So approximately what percentage of women have shoe sizes in this range? Remember, those middle one deviation away is 68%. What range of shoe sizes would include approximately 95%? So 1.5 less than that is 4. Another 1.5 up is 10. So from shoe size 4 to 10 would have 95%. So that's a lot. Small foot to big foot. Beanie Babies. All freshmen entering What's the Matter You have their heads measured for the beanies they are required to wear. 1 year, their head circumference data had a normal distribution with a mean of 55 centimeters and a standard deviation of 1.7. What percentage of the students that year? So let's erase this and put in the new data. So they had a mean of 55 and a standard deviation of 1.7. So if I add 1.7 to this, that's going to be 56.7. If I subtract 2, that would be 53. So that's going to be 53.3. If I add 1.7 more to this, 1.7, so that's going to be a 4. So 58.4. If I subtract 1.7, have to borrow, so that'd be 16. I borrow, so that's a 2, so that's a 51.6. What percentage of students that year had a head circumference between 53.3 and 56.7? So again, that's the middle, so that's 68%. What percentage had circumference above 58.4? So remember, 58.4 is up to 95. So that's 95% between those. So that means there's 5% between the part above and the part below. So if I split the 5% up, 2.5% has to be here and 2.5% has to be here. So above 58.4 would be 2.5%. So that would be looking at that one. So the dental hygiene, suppose you want to know how often people brush their teeth every day, so you take a survey. Explain why the survey results would indicate far more gleaming smiles than actually exist. In fact, such a survey would indicate about twice as much brushing as actually happens. Well, most people don't want to tell you they don't brush their teeth because they'd be like, ew, that's gross. And so they're not going to be like, hey, I don't brush my teeth today, but I do it tomorrow. I only brush my teeth in the mornings, or I only brush my teeth at night. So suppose you want to know how often people brush their teeth every day. You take a survey. That survey is going to be wrong because people are going to lie on this. They don't want to tell you the truth that, I really don't brush my teeth. Okay. Even though it's a survey and they're like, well, nobody will know. People don't want to tell you the truth about something that's gross about them. Okay. So they're going to lie so that there's not this grossness about, oh, he doesn't brush his teeth type thing. So anyways, that's why on that one. So number 17, 9 a.m. versus 9 p.m. You take a survey of students in the library at 9 a.m. on Saturday morning and ask, how many hours per week do you study? You ask the same question at 9 p.m. at a wild party. What would you expect to see in your data? Explain the biases. Okay, so we're going to talk about the biases from that data. So if you're thinking about this, who are the people that study? Well, if they're on a Saturday morning at 9 o'clock a.m., those are probably the people that study quite a bit. Okay, you ask the same question at 9 o'clock p.m. at a wild party, most likely these are the people that don't study as much. Okay, so these guys are going to have at the party, their mean and median and is going to be very low, and these guys are going to be very high. And so you're not going to get a real good sample because you've taken it from two extremes. You've taken it from the wild party people and the 9 a.m. on a Saturday morning type people. If it were at 8 o'clock a.m., you'd even get a more biased thing, because who's going to wake up at 8 a.m. on a Saturday morning to go study? I mean, mostly those are your diehards versus, 9 p.m. at a wild party, not just a normal party, but 9 p.m. at a wild party. If they've started a wild party at 9, most likely they do that all the time. So, anyways, that would just give you some biases in that, and you'd see the different things. The 68, 95, 99.7 rule, referring back to discussion in this section, what do you think this rule means? So this, hopefully you've got this by now. The normal bell curve, one deviation above and one deviation below is always 68%. If I go 2 deviations above and below, between these is 95%. And if I go to 3 deviations, that's 99.7% of my people will fit in this model somewhere. Okay, so that's what that means. Heads up, the marching band is getting new uniforms. Measurements taken include the head circumference of all band members. Suppose these data have a normal distribution. So we have a normal distribution. And so suppose these data have a normal distribution, that 68% of all head measurements are between 54.1. So we don't know what the middle is, but we know 54.1 and 57.9. Whoops. Scribbles. 57.9. So if I took the average of those two, I could figure out what that is. So I could go 54.1 plus 57.9, then cut that in half. That's 56. So my mean is 56 on that. Okay. So anyways, the mean, one right down the middle, is always, we're going to go the same amount above and the same amount below if that's 68%. Use this information to write 2 equations that relate the mean mu and standard, whoops. Well, we didn't write an equation, but that's what it is. And then the standard deviation would just be the mean minus this, or plus this. So I go 57.9 minus 56, which would be 1.9 for that. So unless I just messed up on my math, hold on. All right, so that gives us our standard deviation and our mean on number 28. 29, knees up, building on the previous problem. Suppose an in-seam measurement was also taken for each band member. Suppose these data have a normal distribution. The 99%, 99.7, so remember 99.7 is 3 deviations out there. Okay, so that's this one out here. Lie between 28 and 36 inches. So again, if I want to find the mean, okay, so if I want to find the mean, I can take the average of those two, so 28 plus 36, and divide it by 2. So if I borrow 2 from there, that makes 30. 64 divided by 2 makes 32. And that should be the same, so there's 4 above and 4 below. Use this information to write 2 equations that relate the mean mu and the standard deviation sigma for the in-seam measurements. Now solve for those 2 things. Now I realize that to get to this, I added 1 standard deviation, and then I added another standard deviation. So this is the 3rd standard deviation that I've added. So really what I've done is I've gone 32 plus 3 of these to get up to 36. So if I minus 32, I have 3 of these standard deviations equals 4. So my standard deviation is just 4/3. Okay, so it's 4/3 of an inch. The last problem, the most popular pizza place near campus is Mother Brown's, which is famous for the amount of cheese put on the pizzas. Your school orders 200 pizzas for a big party. That's a lot of pizzas. Assume the amount of cheese per pizza is normally distributed if the average mean amount of cheese per pizza is 12 ounces. So here we go. Oops, that's not a real great one, but we'll pretend it is. So that's 12 ounces, and only 5 pizzas have more than 13.6 ounces of cheese on them. What is the standard deviation for this cheesy data? So 5 out of 200 is what percent? So let's grab our calculator. 5 divided by 200 is 0.025. Hey, that works out nice because remember that's the top of this or bell curve. Remember we have like, oh, these bell curves are getting worse. So this is one deviation above and below is 68%. That's 95%. So 95% means that I have between these two, so 2 above and 2 below is 95%, which leaves me 5%. So that's 2.5% here and 2.5% here. So when it says only 5 pizzas have more than 13.6 ounces, that's our second standard deviation because there's only 5 above that. So that's our above line. What's the standard deviation for this cheesy data? So this is going up 2 standard deviations. So 13.6 minus 12 equals 1.6. And since that was for 2 of them, I'm going to cut that in half. So the standard deviation is 0.08, not 0.08, 0.8 ounces of cheese. So that's how much we could be off. You know, this would be 11.2 and would go 8 down from that would be 10.4, and this would be 12.8 and 13.6. So most of our pizzas are going to be between 10.4 and 13.6 ounces of cheese with fewer than, or 5 would be fewer than 10.4. So anyways, that's those ones. So now let's look at the next section. Maybe. Okay, you're supposed to make a histogram of all this stuff and a 5-number summary. So it's going to be kind of rough. So what I would do is I would take all these numbers and plug them right into my calculator. So I come on over to my calculator. And I'm going to have a piece of paper in front of me that has them all on it so that I don't have to go back and forth. And that's a lot of numbers. So anyways, let's go ahead and get started on that. So I'm going to go to Edit. I'm going to clear out my list 1, and I'm going to start putting them in. So 21, 22, 41, 46, 50, 50. Save you the agony of having to listen to me the whole time. I'm going to pause it, and then when I get it all done, I'll come back. Just thought of another way to do this. I'm going to do a frequency list on this too. So I'm going to put in my first spot 21, and over to the right column, I'm going to put how many times that happened. So I'm just going to put a 1 there. And so then I'll put in 22, and that happens once. And I'm just going to go through all my paper and write all this down, and then I'll have my numbers here, and then I'll put in the number of times that it occurs over here. So like this would be 41, and then 46, and then 50, and then 51, and then over here on this one, 41 only happens 1 time, 46 happens once, 50 occurs twice, 51 occurs 3 times, 52 occurs twice, 53 occurs twice, 54 happens once, 55 once, 56 3 times, 57 once, 58 once, 59 4. And so I do that, and then I have to make sure that I have my numbers in here. 52, 53, 54, 55, 56, 57, 58, 59. So anyways, that's what I'm going to do, and then I'll, after I've done that, I'll bring it back up. I've written all these down. I'm at 69. Then I'm just going to type in all the numbers. So I'm to 71, 72, 73. So I'm not doing the quantity right now. I will do that in just a moment. So I'm just going to type these in. Make sure that I get them all right. So 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98. Okay. And so once I've got those, now what I'm going to do is go back up here and now just do the quantity for each one of those that existed. So, whoops. So at 61, now at 61, there's 1, 2, 3, 2, 6, 5, 2, 3, 4, 1, 5, 2, 3, 4. So 75 was 4, now I'm at 76, which had 3, 77 had 3, 78 had 6, 79 had 1, then 2, then 5, then 4, then 3, then 4, then 11, then 8, then 6, then 10, then 8, then 7. 91 had 4, 92 is 9, 5, 9, 8, 6, 7, 2. So they match up. So now that I've got all that information in, then what I'm going to do is hit stat again and calculate one variable stats. My list of numbers is list 1, but the frequency list, how many times they occurred, is in list 2. So I hit second and then 2, and that brings up L2. So now I can hit calculate and hit enter. And now based on that, I can see my mean is 78.79, and I can write down my other numbers as well. So I'm just going to write that down. X equals 78.79. My minimum is 21. Quartile 1 is 68. I scroll down on my calculator. I get that my median value is 83. Quartile 3 is 91, and my maximum is 98. So now I can go back to the question. It said make a histogram and a 5-number summary. Okay. To do our histogram, we'll have to, I'll tell you the numbers that you'll use and go from there. So let's first of all make our box and whisker chart, because we know how to do that. So here's my grid. I'm going to skip quite a few numbers. And then I start at 21. And then I go all the way up to 100. So here's 20. Here's 100. Halfway between would be 60. So that's 40 below. And then 30, 40, and 50. So I need to break this 30, 40, and 50. So I break that into middle. All right, so 30, 40, 50, 60, 70, 80, 90, 100. Okay, and then So my minimum is 21, so I put a dot right here at 21. Quartile 1 is 68, so at 68 I draw a line. My median's at 83, so I draw another line. Quartile 3 is at 93, so I draw another line. The maximum's at 98, so I put a dot there. Then I connect my lines. So looking at this, you can see that there's a lot of numbers. 50% of my numbers are above 83. So 50% of my numbers or 50% of my data is above an 83. And another 50% is below 83. But this is an interesting one. 25% of my data is from 21 to 68. So that's spread out quite a bit. And then 68 to 83 is another 25% of my data. So anyways, that kind of gives you a feel of where your data is. 25% of my, so 75% of my numbers are from 68 and upwards. So that helps quite a bit to look at it. If you scroll down, I'm not sure that it's there, but there's a stem and leaf plot showing you like all these are the 91, 92, so forth, 80, 70, 60, 50, 40, 30. So that's a stem and leaf plot on that. Okay, so now for the histogram, I'll give you some more numbers and then we'll work on that. So let's start at 21 with the class width of 11. A lot of times it's easier to actually write this down kind of like this. We'll go 11 and then, it's not 11, 21. Then just add the 11 onto here is 32. That's not showing up real well. Add another 11. It's 43. And then 54. 65. 76. 87. 98. Ooh. I was hoping that that 98 would be on our end right here, but that's going to be actually above. So that's just the way it works out. So 21 to 31, 32 to 42, 43 to 53. So it's just one number less than these. So once I have my starting number, I add 11 to each of those because that's what I tell you to go a width of 11. So you just go 21, add 11, add 11, add 11. And this is the same thing, you're adding 11 over here, or it's just one number short of the previous, like 65 to 75, just one number short of the next one's 87, so that's going to go to 86. The next one's 98, so that goes to 97. And then I just add 11 to that, and that's 108. Okay. So anyways, that's how that looks. Maybe if I start at 20, that would work better. So if we start at 20, that gives us 20, 31, 42, 53, 64, 75, 86, 97, 11, 11, 11, 11. Not much difference on that, so we won't worry about changing it up any. Thinking out loud, sorry, and I didn't hit pause. So anyways, now what you've got to do is you've got to count how many numbers are there between 21 to 31. So 21 to 31, there's two numbers. 32 to 42, one number. 43 to 53, so 53 is where I stop. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 54 to 64, so I stop right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21. I'm just going to count how many there are in a full column. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So now my next one goes from 65 all the way to 75. So there's a full 20, then 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. And then 76 to 86. So that's 19. That's 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 and 19 make 30, plus 20 more makes 50. Now 87 to 97, so that's to here. So that's 20, 20, 20, and 18 plus the 1, so that makes 19. So 60 and 80, 20 more would make 80, but it's 1 shy, so 79. And then 98 to 108 is 2. So now that we have that, we come to our drawing of our table, our histogram. Okay, I'm going to jump a few numbers, so I put that little box there like that. And because I'm going to just go halfway between 31 and 32 is 31.5. So I'm going to go 20.5, 31.5, 42.5, 53.5. These are all supposed to be the same width, but I didn't do very good. Let's do better. So I have 1, 2, 3, 4, 5, 6, 7, 8. So 1 there, 1 there. So I need 8 in here. Okay. So now 20.5, 31.5, 42.5, 53.5. So I'm just looking at these numbers on the right side and just adding a 0.5 with them. 64.5, 75.5, 86.5, 97.5, and 98.5. And then on these, I'm going to count by tens. So 10, 20, 30, 40, 50, 60, 70, 80. Okay, so 10, 20, 30, 40, 50, 60, 70, and 80. So between 21.5 and 32, 20.5 and 31.5, there's 2. So it's going to look like this. Little itty bitty, something like that. Then 1 is even smaller. And then 10, so that's right on that line. We should have had a little graph paper for you. Then the next one's 21. And the next one's 35, so that's like right there. And then the next one's 50, so that's like up here. The next one's 79, so that's almost at 80. And then between 97.5 and 108.5, there are 2. So that's what our histogram looks like. Again, I will give you the starting point and the width, and then you'll need to come up with a table. They call this a frequency table. How many times do things occur in between? You'll have to come up with a frequency table. Okay, so remember you start with the beginning number, which is 21. Then you just add 11 onto it each time. Okay, and so that's going to give you these numbers, they call them classes. Gives you the bottom number, and then once you know this number, you can just go one less for the next one. So one less than that. And then you go to your table of you go to your numbers and you calculate how many there are between 21, including 21 and 31, and you write it down. And then once you have that, then it's just a matter of putting it on a chart. You count out how many times it happened up here. Down here, you'd have some title like these are maybe test scores, and you would write frequency and do that kind of stuff with it. So anyways, that's how you would do that. And that also gives you your mean, your median. You know, we wrote the median down, which was 83. So because of these numbers that were very small to begin with, it really pulled our mean down. So we would say this is skewed to the left because you could, like, if you think of this as whatever kind of animal that was, you know, this is the tail out here. If you pull on the tail, that's the way it's skewed because these numbers are pulling things. It's pulling the mean down. That's why it's skewed left. They're pulling the mean down. So, anyways, that gives you an idea of how to do a box and whisker, a histogram, and then when we scroll down, that shows you the stem and leaf chart plot too. So, anyways, hopefully that helps, and that's the end of the stuff we're learning for chapter 9, and that helps you for the final as well. And then when you're all done with that, you're done. So good luck with that.